this last big idea of limits, how they're used in calculus. And you're right, you knew it was an integral. And I'm going to save a lot of the complicated mathematics for when you get to calculus, because what I really want here is for you to understand the biggest ideas of this. It's why the questions are not too hard. But let's just say, right, the idea is we want to find the area underneath this curve. And to do that, we need to know where we're starting, right? What part of the curve are we interested at? So we're arbitrarily saying this left endpoint, right? The leftmost part of this we're defining as A, and for right now we're using B as the rightmost part of this, but we're going to see that the notation of that can be done a little bit differently. And how kind of the spacing of each of these widths, right? How much is each of those is going to be however long this distance is, which we find by saying B minus A, right? However long this is, dividing it by however many times we want to divide it up. And we can kind of intuitively understand that there's going to be, right, we're going to have some height here at some point, right? So there's going to be a degree of over and underestimating, because we're finding the area of a bunch of rectangles, so the height of the rectangles isn't going to change each time, right? It's going to be some sort of height someplace. And it's going to be, we're going to find that height by putting in a value for x, like so we could find the height here or so forth. But we're going to have some over and under estimates, but the more rectangles we have, the closer we're going to actually get to this actual area. So that's the biggest idea. That's why it's a limit, right? Because it's our limit as we divide this up indefinitely, right? Imagine just having more and more and more rectangles, it's going to become more and more accurate to the actual. All right, so to find the area of any rectangle, we need, right, a base times a height, right? It's going to be a perfect rectangle. It's not going to have this curve. It's going to be a perfect rectangle. And so we need to figure out, well, how do I find the base times the height? And we need a beginning and an ending, because we're not going on forever. So we start with this idea of, well, how do we find, what's the base going to be? Well, the base is this change in x. It's this distance between here. And like we said, it's the end minus the beginning divided by the number of times we want to divide it up. All right, and then this is just talking about, well, we have these intervals, right? And these intervals are going to go on indefinitely. That's why it just says n minus 1, however many times we divide it up. Minus 1 is going to tell us how many of those little boxes we have. We could also talk about where is it located, right? So, and this is talking about the interval. So the right endpoint is always starting here at A, and the next point is going to be A plus that change in x, right? A plus the change of x. A plus 2 changes of x is A plus 3. So we're just going from here to here to here and so forth. And then we want to get to the very end of this. So how do I know where the end of it is going to be? This is talking about the area, right? So this is talking about the heights of these. So it's saying, okay, we're gonna edge off these at a place, right? And the question is, do we go from here over, or do we go from here over? So the question is, this is talking about whether we're going to have an overestimate or underestimate at each point. So we either have to come up to we either have to take x1. So this is saying, what is the function at right here at x1, right? That's the height that we're going to take. This is our height times the change in x. So now we have an area. So we're going to take it here, and we're going to come over. But we could do that the other way, right? We could also say at A and come over, right? So this is why there is 2 different ways of doing this, whether we're coming from this direction, so we're coming here and over and making rectangles, or we're coming here and over. Either way, we have to find a height, and we know the base is the change in x, and we're going to find the area. And so this is just kind of going over this idea that as I continue to make more rectangles, right, I'm going to get an area that is more accurate. And that's, this crazy definition is just that. Height times a base plus a height times a base as many times, this is why n's going to infinity, right? As many times as I want to subdivide it up, right? We don't write it out long because this is a summation, so we're using the summation notation, right? We're starting with one rectangle, that's why k equals 1, and then we're going 2, 3, up to infinity. All right, so I think that you can kind of see that this is always going to be the width, right, of the rectangle is always going to be the change in x. The right endpoint, right, is going to be however many times I go over there, right, because the right endpoint is over here. The left endpoint is always a, so we need to figure out, well, how many times am I going over there? However many times I'd subdivide this up, right? I'm going to keep counting over. And the height is always going to be putting in the value, right? I need to know that the change, however many change of x's I'm over, plus my starting point, I substitute that in for the function, and that's how I find the height. All right, let me know if this helps.